I'm Nick Merricks. I work for Landis Gyr, and we make smart meters. So I just wanted to talk today about what the smart meters that we make, the smart meters that are being rolled out today across Great Britain, and how we see the smart meters featuring in the future energy system. Now, before I joined Landis Gyr a few years ago, I worked in a different industry. I worked in aerospace, and I managed a reasonable portfolio of products, about 150 products. And I knew I wanted to work in the energy sector. It was such a fascinating, progressive industry, and there's so much exciting stuff going on. So eventually, Landis Gyr took pity on me, and they invited me to an interview. And I was talking to the chap that was interviewing me, and he said, "You do realise you manage 150 products at the moment in your role in aerospace. You realise this is just for one product, a smart meter." And I said, "Great, this will be easy." How wrong I was. It completely is not easy. It's a very complex and exciting challenge, but there's no doubt that the smart metering system, and it's a criticism that's often levelled at the smart metering system, that it is very complex. And another criticism is that it risks consumers' privacy, data privacy. And I wanted to talk a bit today about how, yes, it is a complex system, but what we get back in return for that complexity is a fantastic capability. And the work that governments, industry, and academia and others have done to build out this system, which is rolling out today in people's homes across Great Britain, is really a fantastic achievement. And also to make the point that consumer privacy, data privacy, really, and security of supply, really has been placed at the heart of the smart meter system design. So that's the first of these three questions that I want to ask today, or to talk about today. What do today's smart meters look like? And then the second question I want to talk about is, what do they look like in the future? It's probably obvious to everyone here that tomorrow's smart metering devices are really as much about consumer devices as about smart meters. So smart meters will tomorrow look like washing machines, cars, battery systems, solar panels, and everything in between. And in fact, that intelligence that the smart meter system represents going into these devices, that probably warrants a slightly different phrase or description. So today I'll refer to smart meters sometimes as intelligent devices. And thirdly, I want to talk a little bit about how we see the intelligent devices featuring in the future energy system. In fact, there's a phrase that is often used to describe the future energy system, or the role that these devices play, and the phrase "the grid edge" has come into use. So what that means is, take the system today, which is the architecture on the left, the traditional centralized system, centralized generation and distribution. But as we move towards the future energy system, this will be decentralized and distributed, and the grid edge becomes much more of a feature in the future energy system. So one of the impacts of this is that, of course, security is a system-wide concern, as everyone knows. And if the future energy system is becoming decentralized and distributed, that means we need to think about security as a system-wide. We need to continue to think about security as a system-wide concern. And so I'll argue that we need to enforce system-wide security principles, those principles that have underpinned the smart meter rollout. So firstly, just a bit of context. So Peter explained this much better than me, but I'll just briefly set out the context for this discussion and the framework of the smart meter architecture. So, as I'm sure most people know, so we have the smart meter system, and at one end of it, we have the energy suppliers, the DCC users, the energy suppliers being one, the distribution network operators, and in the future, the distribution system operators, and the other users that Peter referred to, so the smart switching services, the value-added service providers, and so on, which is where the market is really innovating at the moment, very exciting space. At the center, we've got the DCC and the communications networks that connect in and out of the DCC. And the DCC in this context is, as well as being a communications and IT infrastructure, it's also, of course, a center of trust. And that's very important for the security of the future energy system. And then at the grid edge, we have the electricity meters, the gas meters, and the communications hubs that connect those meters to the DCC. So the first question is, what do today's smart meters look like? And here's a smart meter with a communications hub attached to it. And to be honest, it's a fairly simple device in a way. It's a metrology device, fundamentally. It's measuring energy. And so there's in this case, it's a shunt resistor, a metrology element that measures the energy flow with a custom chip to do the analog to digital conversion. And that metrology is a fairly straightforward piece of technology, but it's something that is obviously fundamental to the device. There is a disconnector switch inside, so this is a supply control switch that allows the supply to be disconnected, perhaps if there is a load limiting event, or if it's in prepayment mode and the meter runs out of credit, the supply can be disconnected and reconnected. There's a radio, obviously, so in this case a Zigbee radio connecting the smart meter to the communications hub, and to the other hand devices, the in-home displays, the gas meter, and so on. And the communications hub obviously has the WAN connection, 3G, long-range radio, depending on the region of the country. And so when you look at this device, it's obvious that there are some reasonably straightforward elements here: the metrology, the switch, the Zigbee radio is getting a bit complicated, the WAN radio getting a bit complicated. And what's really turning this from a traditional, straightforward metering device into an intelligent device is the computing resources on this meter and in the communications hub. So we have quite a lot of computing power now at the grid edge, and that's fundamental to the future of the energy system as we move towards a decentralized system. It's also important to say that the microprocessor is the thing which really determines the security of the smart meter system. It's running the security algorithms, it's running the encryption, it's running who can and can't access the meter, it's running what sort of tariff is working on the meter, it's running the communications back to and from the DCC. It's allowing, just like a mobile phone, it's allowing new software to be downloaded to this meter in the future. So it's really underpinning all the smart characteristics and capabilities of these new energy devices. It means that in the future, security upgrades can be downloaded to the meter. So this concept of grid edge intelligence really has the potential to do some extraordinary things, and I'll talk about that a bit later. But before I do, I just want to pick out two, in fact, I pressed the button too early. There we go. I just wanted to highlight two really important features of of all energy, all electricity meters, not just Landis Gyrs, which are fundamental. So the first is safety, and the second is security. So safety first. According to the regulations, domestic electricity meters in the UK must be capable of delivering 100 amps into your home. And that's quite a lot of current. And I don't know if you get a sense of scale from this. This is quite a small box. And delivering 100 amps through that small box is quite a challenge. So there is quite a lot of technology in these meters to enable that to happen safely. We have special plastics which form the casing. We have special alloys which make up the switch contacts inside. We have very careful electrical design which makes sure that the meter can withstand the electrical stresses that are present in the meter. And then we test and test and test and test to destruction and make sure that we absolutely know that the meter will withstand the worst conditions that the consumer can throw at it. So what we've done, L&G and others, is we've worked very hard to ensure that the smart meters of today are even safer than the legacy meters that preceded them. The second thing that people are rightly concerned about is security, and in that I include the concept of data privacy. So the smart meter system is a fundamental component of the future energy system, and it is therefore part of our national critical infrastructure. It needs to be safe from cyber attack. The security features that have been designed into the system are government grade. The National Cyber Security Centre has defined the security characteristics that must be enforced. And this makes the smart metering system in Great Britain amongst the most secure of its kind. Only organisations which have undergone rigorous checks are eligible to connect to the system. And the private data which is stored on the meter is only accessible to the consumer who pays the bill, and those organisations which are accredited by government to connect to and operate the system. But these security features have not been simple or cheap to implement. They have been hard won. It's taken many years of development to implement them. But now that the system is up and running, we have an incredibly valuable and incredibly secure capability for the country. So while this talk is entitled Smart Meter Hardware, it's obvious that this hardware is nothing without the software that runs on it. And I'll just highlight a few of those software features that run inside the meter. So time of use tariffs, and Peter alluded to these earlier, they enable intelligent devices to vary their behavior depending on pricing signals. And I think Phil from Octopus Energy will be talking about that a bit later. We can conduct a secure change of supplier. So if the energy supplier changes, if you as a consumer want to switch, then that can be done in a way which is secure and where the security encryption keys are passed safely from one energy supplier to the next. Prepayment capability allows consumers to pay as you go, which is very popular and enables them to use a mobile phone to top up or to manage debt repayments, look at their energy usage. And the meter can provide instantaneous energy reads. And so we get near real-time data on energy flows, two-way energy flows at the grid edge. Power quality data is another feature which is useful for distribution network operators and distribution system operators to be able to assess the load and condition of their network, detect and localize faults, stress, and the onset of failure. And these capabilities are all on SMETS2 meters today, and they're all applicable to the intelligent devices of tomorrow. Which brings me now to the second of the three questions that I want to talk about today. So let me explain a bit about what we mean by an intelligent device. So traditionally, these great features available in SMETS2 devices, the role has been quite a simple one. It's to measure energy, to enable the energy supplier to provide a bill. So in the future, if we have all this capability and we have enough computing power to extend that capability, then that opens up some pretty exciting possibilities and benefits to society. So let's take a look at just two of these, and two pretty obvious ones, hopefully for the audience here, but interesting to talk about electric vehicles, firstly, and secondly, microgeneration. So electric vehicles clearly are not just about mobility. I mean, mobility is obviously a very important use case and will be very important for consumer pull of these capabilities into the market. But these devices, electric vehicles, also offer flexibility to an intermittent energy source. So renewable energy is clearly intermittent. Electric vehicles can provide some of their energy back to the grid at times of peak demand or intermittent supply. And that connection back to the grid can be measured either at the electric car charge point or in the car itself. So we need smart meter capability to be embedded in the smart chargers or the electric vehicles. These smart features need to include two-way energy measurement and potentially time of use tariffs acting as demand response signals. And we will need other smart charging capabilities, for example, direct energy demand control. So if we think about SMETS as a minimum standard, it's often referred to as a minimum standard. That means that we are free, or at least I believe we should be free, to develop these smart charging capabilities as an extension to SMETS and allow SMETS to build on the secure backbone of the smart metering system and provide smart charging capability as a secure service to customers. And if smart charging is providing flexibility to the grid, then it's critical national infrastructure and it needs to be protected as such. There is, of course, a number of approaches we could do this. Either we could allow industry to innovate freely over and above the SMETS minimum standard, and that, of course, would help the market to develop those products and services quite quickly. But it could be confusing to the market. So the alternative would be to define those standards carefully and ensure that we have interoperability, which can be a valuable stimulus to a nascent market. Whichever way we do it, we need to ensure that this critical national infrastructure is built on a secure foundation. The second important use case is microgeneration. And as this becomes increasingly important to the future energy system, more and more people are fitting solar panels to their roofs. The cost of those solar panels is coming down all the time. And battery systems are going to be installed in people's homes to help them make the most of their assets that they've put on their roofs. They can sell their energy back to the grid, back to other users, other DCC users, and they can make money from their solar panels. People, we could expect, would want to do that. And so solar panels and home batteries will become intelligent devices that need to measure the two-way flow in and out. And just like the electric vehicle scenario, we may wish to extend SMETS to allow these intelligent devices to interoperate. If we do, we'll be building on the bedrock of security and privacy that the SMETS system presents to us and provides to us. So let's just take a quick digression to look at some market numbers. So let's start with an assertion that there are 27 million households in the UK. That was the basis of the smart meter gap analysis or impact analysis that led to the business case. And let's say that that stays roughly constant until 2050. So starting with the smart meters themselves, we're already underway with SMETS 1. In fact, SMETS 1 is nearing completion. And the SMETS 1 meters will then, of course, transition into SMETS 2 meters, and the rollout will continue out for a few years more until we've installed meters in all 27 million households in Great Britain. So that's meter sets. So 3-4 devices per household. You're looking at quite a lot of devices here, 100 million devices or so. If you then think about the smart chargers and the electric vehicles and the solar panels and the battery systems that might come after them, then you're talking about an awful lot of devices. And we could be talking about up to 200 million devices just for those 2 or 3 use cases that I've described. So this is really the Internet of Things almost. It's a big infrastructure, and it's the future energy system that we're talking about here, which will comprise, as I say, our future critical national infrastructure. We must ensure that these devices securely connect within a rigorously designed security architecture with a well-designed accreditation and certification scheme. So let me address the last of the 3 questions that I wanted to pose in this talk. How do these intelligent devices fit into the future energy system? Well, we've looked at today's smart meters, and we've seen how smart meters could be generalized into intelligent devices. And those intelligent devices can be embedded in smart chargers, smart vehicles, electric vehicles, solar panels, battery systems. Now the question is, how do we connect those devices together? How do we distribute our critical national infrastructure across all of our homes and businesses in a way which is secure and allows the consumer to retain control of their data? We already have a good candidate for that communications network. So here is the smart meter system that exists today, operating securely from endpoint to endpoint. The DCC at the middle acts as a center of trust. And here are the future intelligent devices that will form part of the future energy system. The system has been designed with all the security characteristics that are needed for the future energy system. The technology and the governance processes, particularly the governance processes, are in place. And important to remember that this is not just a technological set of security structures. The security governance processes are also very important. So what we need to do now is build on this secure platform, generalize the smart meter specifications, and potentially extend them to encompass electric vehicles, microgeneration, and other use cases. This is therefore a challenge which is not just about technology choices, but also about how we work together as an industry to develop these specifications to an appropriate level of detail. Government has led the development of the Smart Energy Code and the supporting documents such as SMETS. Landis Gyr encourages government to continue this good work and to go further to help industry to work together, to stimulate innovation, building on the secure platform that is already in place and regulating for outcomes rather than just protocols. It is often cited that SMETS is a minimum standard for interoperability, and industry should be free now to innovate over and above that minimum standard while retaining the security features that are so fundamental to the success of the future energy system. In fact, Landis Gyr is already developing the technology that exists inside the SMETS 2 meters today into a new portable hardware and software platform for intelligent devices. This platform will conform to Great Britain's security requirements. It will run apps in the same way as a mobile phone. For example, you will be able to download an EV app or a home battery app. In conjunction with communications hub functionality, it will connect to the DCC, and the software that runs on it can easily be ported to other proprietary hardware platforms. This is Landis Gyr's view of the future of smart metering and the future energy system at the grid edge. I do appreciate that there are lots of alternative viewpoints to this one, and there are many standardized IoT, smart energy technologies that could be brought together to achieve the same functions, but none of them provides the same level of end-to-end, system-wide security that critical national infrastructure demands. So how do we proceed? I've outlined how we think the UK's investment in secure smart meters has resulted in a fantastically capable and secure system, which allows the consumer to stay in control of their private data. And we have seen how smart meters are just the beginning if we're to achieve our energy goals for the future. Smart meter capability now needs to be extended into the future intelligent devices that will form the future energy system. It will take some time to get the regulation and the market propositions right so that we strike the right balance between over-regulation, which could be stifling to the market, against unconstrained innovation, which could be confusing to the market. But we need to accelerate our efforts to ensure that we can bring the future clean energy system to life as soon as possible. Thank you for listening. And if you are interested in knowing more about how Landis Gyr is investing in the future energy system, or if you're interested in being part of this future with us, please do come and find me or my colleagues in the intervals, and let's discuss what we can do together. Thank you.
Okay, thank you. Thanks, Nick. Okay, before we go into coffee, are there any questions for Nick? Just pop your hand up if anyone have any questions. Oh, there we go.
Is it working? Sorry. Stu Birchall, I'm from a company called Zen Internet, so we're a service provider. Just a quick question regarding the access network, because I wasn't familiar with how that DCC network works. You mentioned edge computing. I'm assuming that needs bandwidth, and I noticed that in the north of England there is a radio network that's run by Arqiva. Will that deliver enough bandwidth for what you're planning for the future, or will that need to change?
So my view is that this will deliver enough bandwidth for the future as we see it. And of course, there is the theoretical trade-off between computing resources, particularly memory, and bandwidth. You can interchange one for the other to a degree. And the future smart devices are going to only get more capable as far as their computing resources is concerned. So even though today the bandwidth is, and for the future the bandwidth is going to be difficult to increase at the same level as the computing resources on the devices, from what we know today, I think that bandwidth is perfectly sufficient to do what we're envisaging.
The device that you showed on the, Adam from Switchy, the device that you showed on the last page, is that effectively a CAD? And are you able to share any kind of timelines around when you're going to have that ready?
So this is not a CAD. It's a smart meter. It contains all the functionality of a smart meter, but goes further to generalize that capability onto any hardware platform. Timelines for this are probably not at the stage yet where I can commit any particular timeframes, but the firmware, which is the difficult, time-consuming bit to develop, has, of course, already been developed. It's existing on smart meters today. All that capability is being built out, and crucially, it's been certified. That's the really important bit to get from something which works to something which is proven to be secure. And so, how we can build on top of that, I think it's it's not years and years away. It's close.
Okay, any more questions for Nick? Oh, one down.
Hi, Nick. My name is Nigel Smith, Tensor PLC. We manufacture heating saver building management system. Most of our customers are commercial, also SMEs, but of course they're mainly three-phase, and we're having immense trouble finding right now any three-phase SMETS2 meters. Do you intend to make them?
We do, yes. They are on our roadmap. We're having to prioritise SMETS2 full terminal meters at the moment, single-phase meters. That's got to be the focus of our energy just for now. But in the near future, we do expect to have a polyphase meter entering the market with SMETS2 capability.
Are you actually going to also give us a breakdown of L1, L2, and L3?
Sorry, what do you mean by that?
Well, obviously it's three-phase. You've got three power lines, basically.
Ah, okay.
And rather than have a combined output, which is one of the problems you get with ordinary meters, you really need to know what's being drawn on each one of those three phases.
Right.
Is it your plan to be able to make sure that we get that data too, not just the combined use?
So off the top of my head, I don't know if that's in the spec for our meter, but clearly they'll be SMETS compliant. And Peter will probably remember off the top of his head whether that's in the SMETS spec. I've got a feeling it is, but we'll be providing meters to meet the SMETS spec at least, if not beyond that.
Okay, time for one more question.
Good morning. Great talk. I'm Jill Kelleher from the Active Building Centre at Swansea University, looking to turn buildings into active buildings. So quite a loaded question for you, so I don't expect a direct answer. Okay. So why are we still pricing these intelligent devices based on an old market cost framework?
Do you mean the hardware cost?
No, I mean the cost of the benefits of all these technologies. It means that we don't need...
Okay. Well, so others are better placed to answer this perhaps than me. I would say that it's because we don't factor the cost of carbon into the cost of our energy. If that were to happen in a way which truly reflected the societal impact of carbon, I think we would have a different pricing framework.
Absolutely.